Okay, to finish up section 2.4, we're going to look at a few final things here, and we're going to cover something called the substitution method. This is for using continuity. So I'll say substitution method, and I'll just say continuity. So how this works is, suppose you have a limit as x approaches c of f of x. And let's say we want to evaluate that limit. Well, if we know that f of x is continuous at the c value, then we can use the equation of continuity, and this will say that the limit as x approaches c of f of x is f of c. So to evaluate the function, we can evaluate it by replacing the x's in the function with the c. So since we're plugging it in, that's kind of why they call it substitution method. So we're going to look at a few examples of how this works and see kind of how that goes. So we'll say limit as y approaches pi over 3 of sine of y. That'll be our part A thing that we're looking at. And then part B. Part B will be, what about limit as x approaches -1 of 3 to the x, all that divided by the square root of x plus 5. So to evaluate this, it's going to be pretty easy. We just go through and say, all right, first of all, sine of y is continuous, so then this limit is going to equal sine evaluated at pi over 3. So if we think about sine of pi over 3, that should be, I believe that's square root of 3 over 2. So let me just verify that real quick. Set my thing to, oh yeah, in this AP class, you guys need to make sure you set your calculators in radians. So that's going to be square root of 3 over 2. And we get our answer that way. For this one here, so this is an elementary function. So this right here, it's a division of some of those basic functions that we were talking about. So this is continuous. So since it's continuous, if we want to evaluate it, we want to find its limit as x approaches -1. All we have to do is substitute our numbers in for the x's because we know it's continuous. If the function is not continuous, you can't do this. So if this is not a continuous function, then you're not allowed to do what we're doing here. So you get 3 to the -1, that's square root of 4. Square root of 4 is 2. 3 to the -1 is a third, so this is a third times a half, which is 1/6. And we get our answer that way. So that's this example. Just basically you need to verify that the function is continuous where you're looking at it, and once you verify it's continuous, you're able to use it. The last example we're going to talk about is they want us to look at the limit as x approaches 2 of this symbol right here. Our book uses this for the greatest integer function. So our book calls that the greatest integer function. And what the graph of this thing is, so you guys kind of can see this. This is like the function that always rounds down. So every decimal is 0, gets rounded down to 0 until you get to 1. Then at 1, 1 is 1. 1 in all decimals, like 1.3 is still 1, 1.4 is still 1, until you get to 2. So it's a little step function like this that basically every time you hit the next whole number, you jump up to the next step, and your y's stay there until you get to the end. And then over here, you get kind kind of just continues on like this forever. Well, the problem is limit as x approaches 2, that is here, and we're not continuous there. We have a jump discontinuity. So we can't use the substitution method because there's a jump discontinuity. So what you have to do is you can't use the substitution method, so we're going to have to look at the left and right hand limits. If we want the two-sided limit to exist, we have to kind of, we'll do it graphically in this case. We'll look at the left side limit, see what that is. We'll look at the right side limit, see what that is, and see if the two-sided limit exists, if the left and right side are equal to each other, and then we'll be able to say kind of what that is. All right, so as we approach 2 from the left, 2 is here. So we approach it from the left. We're down here on the previous step, so our y value is 1. When we approach 2 from the right, we are up on the next step here, and our y value is 2, so our limit as x approaches 2. This limit does not exist because the left side limit's approaching 1 and the right side limit's approaching 2. They're not approaching the same number. So this two-sided limit does not exist. And we were not able to use the little substitution trick on this because the function that we were dealing with was not continuous at 2. So we couldn't apply the continuity substitution trick using continuity because we weren't continuous. So that's going to wrap that one up.